Lesson 13 may seem like out of the ordinary why we're jumping from like quadratics. Why in the middle of our quadratic unit we're talking about a lesson on simplifying radicals. So as you noticed when you were you're taking the square root of values, some of you didn't keep simplifying. You left square root of 16 or square root of 36 in your problem. And the big idea here is that you need to realize that radicals are still solutions. They're rational or irrational numbers. And some of you leave them and some of you don't leave them. But sometimes they can be simplified. Sometimes it's easier just to leave them as a radical if they can't be simplified. And they can still be utilized in expressions and equations. So the big idea for this unit is that we're finding solutions to an equation, and that um, our values aren't always just whole numbers. They can be decimals, they can be fractions, they can be radicals, and we need to know how to simplify them and when to simplify them. So on my first page here, I did post a lesson completed for this I'll post it online, but it's kind of hard to follow. So I'm going to walk through some stuff here, but I'll leave that there in case like you need another reference point. But here are just some values that when we square them, what we get. And these are our perfect squares. So 2 squared, 3 squared, 4 squared. We went over this before we left for quarantine. And if we took the square root of these values, we would get the value that we got was squared. So square root of 4 is 2. We go back to 3. We go back to 4. But remember when we solve for quadratics that these can be positive or negative. So if I did the square root of 25, I would get 5 or negative 5 because 5 squared is positive 5 squared is 5 times 5, which is 25. But this is also negative 5 times negative 5, which is also a positive 25. So since I can get either both the same answer with using either number, I have to make sure that I know that they're both. When you do simplify radicals, I'm going to tell you that you're only using a positive form. Okay? So when you do take the actual square root, you're getting a positive or negative value. But we're going to practice just simplifying when given the radical. So let's first do some numbers. So let's try radical 50. So if you have radical 50, you want to simplify that. I don't want you to put it in the calculator. I don't want you to get decimals. Okay, so we're going to use it. We have to find two numbers that multiply to 50 where 1 is a perfect square. And you can take notes on this if you want. I would, if you're not going to remember. So you have to think to yourself, out of this list of numbers, so right here, out of this list, so these are our perfect squares. Which one, I don't know why this isn't working now. Which one of these goes into 50? So two numbers that make 50, one has to be a perfect square. So we have 25 and 2, right? 25 times 2 does equal 50. What we're going to do is put them both under radicals. We're just simplifying the radical. So radical 25 times radical 2 does equal radical 50. So I'm breaking radical 50 down. Now I want one to be a perfect square because what's the square root of 25? Just 5. So my answer is just 5, radical 2. And again, for this, we're just going to make the 5 positive. But when you do simplify your quadratics, you should have a positive and negative. So I'm going to write out the perfect squares here. So we have 1, even though you don't really use that, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So when I simplify my radicals, I would need one of these to be in my problem. Need one of these because it'll make my life a lot easier. Let's try another one. Let's try radical 72. So what two numbers multiplied make 72? So you can think of, how can we break down 72? We can do 9 and 8. We can do, what else? What else is perfect square? Does 25 work? No. 72 divided by 4 is 18. What else? 72 divided by, so we did 9 already. Does 16 go into it? Nope, I get 4.5. I want nice numbers. 72 divided by 25. Nope. 72 divided by 36. Yep. So 36 and 2 also works. So out of these numbers, which one is the biggest perfect square? It's supposed to be 18. So we have 9, 4, and 36. So I want to use the biggest perfect square that makes 72. So I would want to use the pair 36 and 2. Because if I use the biggest perfect square, then I have less simplifying to do. You could have used 9 and 8. You could have used 4 and 18, but you might have to simplify more. So the square root of 36 is just 6. And then 6 times radical 2 would be my answer. So if you did use 9 and 8, so I'm going to show you. Let's say you said, all right, well, 9 and 8 makes 72. And 9 is a perfect square. Okay, so the square root of 9 is 3. So you have 3 radical 8. But can 8 be simplified? Can two numbers multiply to make 8? That where we can simplify one, where one's a perfect square. Yeah, 4 and 2 make 8, and 4 is a perfect square. So what you're going to have to do is simplify this more. Square root of 4 is 2. Now you have these two numbers just dangling. So what you're going to do with them is multiply them together. So you would have now 3 times 2 radical 2, which would still get you 6 radical 2. So it's the same answer as before, right here. But if you pick two different numbers, that's totally fine, but you want it in simplest form. So you got to make sure all the numbers can be broken down. So can 2 be further broken down? Two numbers that make 2 are only 2 and 1. Can we break down 2 and 1? No. All right, let's keep going. Let's do 2 radical 20. So I'm going to think to myself, what makes 20? 10 and 2 make 20. 4 and 5 make 20. But I want 1 to be a perfect square. So is 10 or 2 a perfect square? No, so I shouldn't use that one. 4 and 5. Is one of these a perfect square? Yes, 4 is the perfect square. So what I'm going to do is, and some of you are going to remember this, right? Like you can always break down 20 into 4 and 5. Square root of 4 is just 2. And then remember, if you have just dangling numbers, what do you do with them? If you have numbers by themselves, you're going to multiply them. So I have 2 times 2 is 4. Radical 5. And then radical 5. Can we break radical 5 down? No. Radical 5 is actually prime, so you can't make 5 besides with 1 in itself. So you just leave it as 4 radical 5. Okay. And the last, I want you guys to practice this before we get to harder ones. What I'm also going to show you is variables. So with variables, we want to make sure that the number is even because the exponent is even. Because if it's even, then we can take the square root of it. So like with x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th. Right, so the square root of this is just x. Square root of this is x squared. Square root of this is x to the 3rd. So we're taking half of that exponent. Square root of this is x to the 4th. Square root of this is x to the 5th. Okay, so I would have that in your notebook as well as a reference key. So if you had something that was x to the 5th, and you want to take the square root of it, you want to break this down into basically the one less than it. So 1 less than x to the fifth is x to the fourth, which means this has to be x to the first, or just x. That way we have an even exponent and we can take the square root of it. So the square root of x to the fourth, if we go back, is x squared, and then we're just left with this. Okay, so whenever you have an odd exponent under the radical for these variables, you want to make one even and one that's odd, usually the one less than. So let's try another one. Let's say we have x to the ninth. So we can break this down into x to the eighth and just x, right? Here's one less than 9 and this one. So what's the square root of x to the eighth? We go back. X to the fourth. And square root of x. Let me just leave it like that. Okay. So I'm going to post the first few here step by step in case you need it. Right, we found the largest square root that divides evenly into the number. Break the radical into 2 radicals. Take the square root of the perfect square and eliminate the radical sign. Leave the number under the radical if it can't be multiplied. Here are some model problems. Here are some more model problems, right? We break the 12 into 4 and 3. Right, x to the seventh. Sometimes you'll have 2. So for homework, and these are a little bit harder ones. For homework, I'll post some problems for you to do based on this half, and then for next time, we'll finish this lesson and do some harder ones.